Okay, guys, welcome. So today we're going to talk about graphing quadratic functions. Um, so we've talked a lot about solving quadratic equations and what are different methods and techniques for doing so, but we haven't really looked at any of these on a graph yet. So that's what we're going to do next. So of course, just to refresh your memory, a quadratic function is something that you can write in this form. So you can write it as something times x squared plus something times x plus just a regular constant. Now, it turns out that the graph of one of these things is what's known as a parabola. So a parabola is sort of a U shape here, which you can sort of see given by these two graphs here. So let's just make a note that a parabola is a U shape, or it could be upside down U. Now, whether or not it's upside down depends on one thing. So if your A, so your term in front of your x squared is positive, it turns out that you have the regular U shape shown here, where the parabola opens upward. And if your A is negative, right, or your coefficient of your x squared is negative, parabola is going to open downward, and then you're going to get that upside down U shape. Now, one thing to note here that's going to come into play later is that whatever your lowest, or in this case, highest point for each corresponding graph is, in the case where your parabola opens upward, your vertex represents a minimum value. And that'll be one thing that we're going to talk about a little later on in this video. And on the other hand, if your parabola opens downward, your vertex represents a maximum. And one more thing that we can comment on is you'll also notice that if you draw sort of this dashed line where your vertex is, you have the same thing on either side of that dashed line. And that's what's known as the axis of symmetry for your quadratic function. So a couple things that we need to talk about are how you can find the vertex. And I prefer to use this formula here. So in order to find the vertex of a parabola, the first thing that you need to do is you need to find the x coordinate, which is minus b over 2a, depending on those coefficients. Now, you could use this expression here to find the y coordinate, this 4ac minus b squared over 4a, but that's one more thing to memorize, and I think that it's just easier to get the y value. You just evaluate the function at your x value, and that's what it's going to reduce to anyway. And one final thing here, I guess not one final thing, but the next thing that we need to talk about is, remember that axis of symmetry, right, in each of these things. Notice that's at the vertex, and since it's a vertical line, it's x equals whatever your x coordinate of the vertex was. So that's where you're going to find your axis of symmetry there. All right. One more thing is in order to find the x-intercepts of a parabola, or in other words, where the parabola crosses the x-axis, you can solve the equation when it's equal to 0, which of course is something that we've done a bunch of times before. You can either use factoring the quadratic formula or by completing the square as well. Now, it turns out that you have different possible graphs depending on what the discriminant looks like. So of course, if your discriminant is positive, that's when you have the two real number solutions, and those two real numbers are your x-intercepts. So that's where those points would look like. So those would be your solutions. If it's equal to 0, you get one real number, and that's where you're seeing this x-intercept here or here. Now, if your discriminant is negative, here's sort of the interesting one. That means you have two complex numbers. But of course, on a XY plane, we only have real numbers, so you're actually not going to see anything. You're not going to see it cross the x-intercept. So that's why it's sort of floating above the x-axis, or floating, in this case, below the x-axis, and you don't see any intercepts there. So you can tell a lot by what the graph, you can tell a lot about what the graph will look like based on the discriminant as well. Okay, but let's put this all together and let's do an example. So we want to graph y equals negative x squared plus 2x plus 3. All right, and we're going to do it in pieces. We're going to first determine if the parabola opens upward or downward. We'll find the intercepts, we'll find the vertex, the axis of symmetry, and then finally at the end we will graph it. All right, but let's start from the beginning. So to determine if the parabola opens upward or downward, we need to look at our a term. Well, our a in this case is -1, and of course that's negative, so our parabola is going to open downward. It's going to look something like this. So we know that it's going to open downward. Now for the y-intercept, that's when you set x equal to 0 and you solve for y. So if we set x equal to 0, we get pretty quickly that y is equal to 3. So that's going to be our y-intercept. Now for the vertex, to get that, we know that the x-coordinate of the vertex is negative b over 2a. So in this case, we're going to get a -2 over 2 times a, which is -1. So we get -2 over 2, -2 over -2, which of course is +1. So that's the x-coordinate of our vertex. Now to get the y-coordinate, I need to plug in 1 into my original function. And if I do that, I'm going to get -1 squared plus 2 times 1 plus 3. So I get -1 plus 2 plus 3, which will give me a 4. So combining these two pieces of information, I know that I have a vertex at the point 1, 4. Now the equation for the axis of symmetry is nice because we've already done the work for it. It's just whatever the x-coordinate of your vertex is. So the axis of symmetry is located at x equals 1. Okay, so now the next step in this is to find the x-intercepts. And again, our equation was y is equal to -x squared plus 2x plus 3. So in order to find the x-intercepts, that's essentially you set y equal to 0 and solve for x. So then we get 0 is equal to -x squared plus 2x plus 3. So now that I have a 0 in there, we can multiply both sides by a -1. So I can get my coefficient of x squared to just be a +1. And I'll get 0 is equal to x squared minus 2x minus 3, which we can factor. So we get a 0 is equal to x minus 3 times x plus 1. So we get that x is equal to 3 and x is equal to -1. Okay, so now when it comes to the graph, we want to first plot all of our known points. So the first point that we found, if we come back up here, was our y-intercept, right? And of course, for a y-intercept, we know that that's a point 0, something. So we know that we have a point 0, 3. So we get a point right here. So that's our y-intercept. What else do we know? Well, we also know that the vertex is located at 1, 4. So that's another point that we can plot. So 1, 4 will, of course, put a point right here. Okay, what else do we know? After we found the vertex, we found the axis of symmetry. So we know that we have a point, we have a line along x equals 1, and it better look the same on both sides of that line. Okay? What else do we know? We know the x-intercepts are 3, 2, 3, and -1. So we also have points right here. So, and we also know that this opens downward. So that kind of aligns with our points that we already have so far. But now we can use something to our advantage. We know that we have an axis of symmetry with this green line here. So what does it mean to be symmetrical? It means that whatever it looks like on one side, it better look like that on the other side. So we can actually take this point here, let me use a different color, and mirror it over the axis of symmetry. So that point is 3 units high, and it's 1 unit away from the axis of symmetry. So if I come out 1 unit on the other side, I'm going to get another point just like it. So that point, we didn't even have to calculate by hand. We could just use the fact that we have the axis of symmetry there. So now, of course, we can connect our points here, and we're going to get something like this. So that's our graph for this one. All right, so let's do another example. And if you like, you can also pause this and try this on your own, and then unpause it and see what happens. So we want to do the same thing. So first, I want to find out if it opens upward or downward. So of course, in this case, my A is 1, which is positive. So that means we're going to open upward. So that's one thing. Part B, we want the y-intercept. So if x is equal to 0, we get that y is equal to 0 minus 3 times 0 plus 4. So we get pretty quickly that y is equal to 4. So if we have a y-intercept, that tells us that we have a point of 0, 4. All right, part C was we found the vertex. And the x-coordinate of the vertex is given by minus b over 2a, which in this case is a negative 3 over 2 times 1. So we get a 3 over 2. All right, so unfortunately we get a fraction, but that's what we have. That's what we're going to have to deal with here. So then our y-coordinate is going to be found by taking the x-coordinate and plugging it in. So we get a 3 over 2 squared minus a 3 times a 3 over 2 plus 4. So now we just have to do a little bit of algebra. 3 over 2 squared will be a 9 over 4. And then we get minus a 6 over 2 and then plus 4. So let's make these all have common denominators. So this one needs times 2. This one needs times 4. And then we get a 9 minus 12 plus 16 over 4, which if we simplify will give us a negative 3 plus 16. So it looks like we get a 13 over 4. So that's our y-coordinate. So using these two pieces of information, we know that we have a vertex at 3 over 2, 13 over 4. All right, so not the prettiest vertex, but that's the vertex nonetheless. So again, part D, we want the axis of symmetry. And again, we've already done the work for that. That's just x equals the x-coordinate of our vertex. Okay, part E, we want the x-intercepts. So if we set y equal to 0, we get that 0 is equal to x squared minus 3x plus 4. And can we factor this one? It looks like we can. So we get a 0. And I need two numbers that multiply to a positive 4 and add to a negative 3. So let's see. Actually, I don't think we can do that, right? Because 4 and 1, of course, will multiply to 4, but not add to negative 3. And negative 4 and negative 1 will also not work. So we actually cannot factor this. So we need something else. So cannot factor. Let's, for fun, we'll do completing the square just for something different. So I'll move my negative 4 over, and we'll get negative 4 is equal to x squared minus 3x. So now my b over 2 squared is negative 3 over 2 squared, which is a 9 over 4. So that's what I need to add to both sides. So 9 over 4, and then 9 over 4. So now what we currently have is 9 over 4 minus 4 is equal to, now if I factor this, I have x, and I definitely need a minus, and then the square root of my last term is 3 over 2 squared. So now we need a common denominator here. And we find that we get a 9 over 4 minus 16 over 4. And then that equals x minus 3 over 2 squared. So we get a negative 7 over 4 is equal to x minus 3 over 2 squared. Now at this point, we don't have to continue. And the reason why we don't have to continue is that this is going to give a negative square root. So since I get a negative square root, I'm going to get two complex answers, and I'm not going to see them. So two complex answers in this case means no x-intercepts. So we no longer have to worry about that. So let's go ahead and we'll graph what we have. Let's try and make a straight line this time. So that's a little better. So now if we want to graph this, we'll just graph exactly what we know so far. So we know that we have a y-intercept at 4. We know that we have a vertex at that horrible fraction, so it's 3 over 2 comma 13 over 4. So of course 3 over 2 will be halfway between 1 and 2. And 13 over 4, let's see, so 4 goes into 13 3 times with 1 left over. So we're going to get something right about there, right? Because we get 3 and 1/4, so it's going to be a little bit above 3. Now, we also know that we have an axis of symmetry at 3 over 2, so we have something like that. Now, since we didn't get any x-intercepts, we may need a couple more points, right? Now, we can, of course, use the fact that this is an axis of symmetry and mirror this point over by a unit of 1.5, right? So it looks like at 3, we'll get another point there. And just to be thorough, we'll maybe plot a few more points. Let's maybe plot what happens when I plug in -1. And that will actually be enough. So if I make x equal -1, then my y-coordinate that corresponds to that will be a -1 squared minus 3 times -1 plus 4. So I'm going to get a +1 plus 3 plus 4. So we get an 8 there. So this will be 5, 6, 7, 8. And we get another point here. But now, again, we can cheat and we can use our axis of symmetry. And whatever that distance is, so that looks like it's what, 2.5 away. So I'd also need to do the same thing on this side, and I'm going to get another point here. So now we can connect our points, and there is our quadratic function. We pretend that that goes through there a little better. Okay, so hopefully that's not too difficult. Okay, now the last thing that we need to discuss here, at least in terms of graphing quadratic equations in this form, is, again, just a reminder that depending on the type of parabola, your vertex either represents a minimum or a maximum. So we can sort of use that to our advantage. So for example, we're saying that a batter hits a baseball at a height of 3 feet above the ground, and we can represent the height of the ball, so this is another projectile motion, is negative 16 squared plus 64t plus 3. So the first thing we want to do is find the maximum height attained by the ball. Well, if we want the maximum height, we want the vertex y value, right? Because we see that our coefficient of our t squared here is negative. So our graph is going to open downward, and our vertex will represent a maximum. Now, since t is the time, part 2 will actually be finding the t value, so we'll actually find that first, and then part 1 will be the y value. So we need the vertex. So in this case, our vertex is t, but it's still negative b over 2a. So we get a negative 64 over 2 times negative 16. So a negative 64 over negative 32. So we get a positive 2. So it's going to take 2 seconds to reach this maximum height. So that's actually our answer to part 2. Now to get the y value, I just need to plug in 2 into my equation here, and we'll get negative 16 times 2 squared plus 64 times 2 plus 3. So we get a negative 16 times 4, which is negative 64, plus 128, plus 3. So that should give us 67. So we get 67 feet is the max height. And finally, in part 3, they want us to find the time it takes for the baseball to strike the ground. So what we need to do there is set our height equal to 0. So then we have negative 16 t squared plus 64t plus 3. So now, of course, this is something that we need to solve using something like the quadratic formula. So if we do that, we'll get negative 64. So t is equal to negative 64 plus or minus square root of 64 squared minus 4 times negative 16 times 3 all over 2 times a, which of course is negative 16. Right? So of course this is going to be quite the mess to find here. So what we're going to do here is we're going to leave it as an exercise to simplify, just for time's sake of this video. All right, but that's sort of what you would need to do in order to find it. Okay, I want to look at another type of example like that maybe be a little bit easier for us to find. So we now want to consider a rectangle with length x plus 5 and width 8 minus x. So first thing we want to do is find an equation for the area. So now, of course, area of a rectangle is length times width. So in this case is x plus 5 times 8 minus x. which we can distribute, and we get an 8x minus x squared plus 40 minus 5x. And if we simplify and combine like terms, we'll get negative x squared plus 3x plus 40. Okay, so we have negative x squared plus 3x plus 40, which represents the area of our rectangle. Now again, notice that your a term is negative, so we are indeed going to get a maximum at our vertex. So now let's find what this maximum is. So of course we need the vertex again. And our x coordinate of our vertex is negative 3 over 2 times negative 1. So we get negative 3 over negative 2, which we can say is a positive 3 over 2. Now our y coordinate is what we get when we plug in 3 over 2. So we have negative 3 over 2 squared plus 3 times 3 over 2 plus 40. And now we have to do some simplifying. So we get 9 over 4 plus 9 over 2 plus 40. And now we need a common denominator. So we have 9 plus 18 plus 160 over 4. So let's see, I guess we get a 187 over 4. And whatever that comes out to be, that will be your max area. And of course, to get the corresponding dimensions, we could plug in our 3 over 2 back in for the length and width. So the length was x plus 5. So we have 3 over 2 plus 5, which I guess would come out to be a 13 over 2. And then the width is a 8 minus x. So 8 minus 3 over 2. And I guess that would be, so we get a 16 over 2 minus 3 over 2, so 13 over 2. So it actually turns out that if the length and width are the same, that's when you maximize the area, or when you have a square. Okay, so again, hopefully that wasn't too bad. The last thing that we'll discuss in terms of graphing our quadratic functions is what if it's presented in what's called the vertex form. So of course you could look at this, you can factor it in such a way that your equation looks like g of x is equal to a times x minus h squared plus k. And of course, this will just shift around the graph of ax squared, right? So when we previously discussed transformations, a lot of this stuff we've already talked about, but just to refresh your memory, this h value is going to result in shifts left or right. And the k is going to be shifts up and down. And sort of the advantage of having it in this form is that your vertex is simply at h comma k. And of course, that means that your axis of symmetry is at the x equals h vertical line, right? So of course, here are some examples, which if you like, you can pause and consider on your own, but we're just going to go right to an example here. Okay, now first of all, I want to graph negative 2 times x minus 1 squared plus 3 using this given graph of negative 2x squared as a guide. So how is this g function different from this f function? Well, we have this minus 1 on the inside, and that tells us that we are shifting to the right by 1 unit. Remember, when it's on the inside of the function there, it sort of works the opposite way you think. And of course, this plus 3 on the end is a shift up by 3 units. So for example, that was our original vertex, of course, at 0, 0. And if I shift it to the right by 1 and up by 3, my new vertex is going to be here. Right? And for example, you could take some other points, for example, -2, 1, and -2, sorry, 1, -2, and -1, -2. And if we shift them to the right and up by 3, we'll then get these points. So we'll get a point here, and then we'll get a point here. So you could find that your new parabola, once you follow these shifts, will look something like this. All right, so that's one example of how these graph transformations work. Okay, so the last example that we're going to do is we're now going to consider an example that we've looked at already. And we're first going to write it in this given form here. Now, if you have x squared plus 4x plus 3, we can find the vertex. And that's going to be at negative b over 2a, which is negative 4 over 2 times 1, which is negative 2. So the x coordinate of my vertex is negative 2. So why would I find that? Because that's going to give me h in this other form. Now to get the y coordinate, plug in negative 2, and that's going to give us a negative 2 squared plus 4 times negative 2 plus 3. So we get 4 minus 8 plus 3. So we get negative 1 as the y coordinate of our vertex. And again, the advantage of that is that that gives us k. So far, we have that g of x. We don't know what a is just yet, but we have x minus a negative 2, so plus 2 squared, plus k, which in this case is minus 1. Now, to get a, we just need to figure out, well, what I need to multiply x squared by to get the coefficient in the original one. Now, in this one, we see that the coefficient in the original equation is 1, so we can conclude that a is equal to 1. And then our formula is going to look like g of x is equal to just x plus 2 squared minus 1. So then there is our function in this new form. So one last thing, we will graph it. So we know that our vertex, again, is at negative 2, negative 1. We know that the graph opens upward, since our a term is positive. And of course, we can see by looking at it that our y-intercept is 3. One more thing that we can use is that we have an axis of symmetry at our x value of the vertex, so that's at negative 2. So we can spot one more point on the other side of that axis of symmetry, and that will be at a height of 3. So we get an additional point there. If you want to plot more points, of course you can. But we'll go with what we have here, and we'll get something like this. All right, so that wraps up this video on graphing quadratic functions. So I hope you enjoyed the video, and I will see you next time.